Let me see if I can find another one. Let me see if I can find another one. I assume this is the preview for section 1.4. And this is not a bad thing to do for, oh no, don't ever do that. Don't ever do that. Oh no. Oh no. Let's see if I can find one real quick. This is not a bad review for this section, actually, for our moving on to section 1.6 today. Just a second. Too many computers. 1.437. Okay, here's a good one. Let me go in here and put another slide in. Okay, so this is just another version of the same problem. So we have negative 12 plus the square root of negative 18, the whole thing divided by 60. Okay, so the first step in this problem is to look at the thing under the square root symbol, the negative 18. Just look at the 18. Does 18 have a factor that's a perfect square? Again, what are your perfect squares? 4, 9, 16, 25, 36, 49, etc. So does 18 have a factor that's a perfect square? What do you think? All right, is 4 a factor of 18? No. Is 9 a factor of 18?
Yes.
Yes. So you can rewrite this. $18 is 9 times 2. Okay, so you have a property that says that if I have the square root of a product, I can write that as the product of the square roots. So the part that I have up here, right here, that I highlighted, I can rewrite that as the square root of -9 times the square root of 2. That's a law. And a law means that I can do it. Right? So if I have the square root of a product, I can write that as the product of the square roots. Okay, so all I've done is just take that square root and rewrite it as the product of two square roots. You have a property from section 1.4 that says that if I have the square root of a negative number, that is going to be equivalent to I times whatever the square root of b is. So the square root of -9 is I times the square root of 9. By definition, that's what it is. So not the square root of 9 is 3. So the square root of -9 is 3i. And again, why is the square root of -9 3i? Because what do you square to get -9? If I take the 3i and I square it, I get 9i squared. But I squared is -1. So the square of 3i squared is -9. Okay. So all I've done from here to here is rewrite that square root. The square root of -18 and 3i times the square root of 2 are exactly the same number. Exactly the same number. Now that I've got the radical simplified, I can simplify the fractions. So you have a property that says that if I have a plus b over c, that's the same as a over c plus b over c. So for example, if I have 5 plus 7 over 9, that's the same as 5/9 plus 7/9. It's the same thing. So I can rewrite this fraction, and I can take each term in the numerator and write it over the denominator. Now I cancel any common factors. Okay, so I have -12 over 6. Well, that's -2. -12 divided by 6 is -2. And the second fraction, I have a common factor of 3. I can cancel that out. 3 divided by 3 is 1, so I can cancel a 3 in the numerator. 6 divided by 3 is 2, so I can cancel a 3 in the denominator. So what I'm left with is, what do I have left up there? I got 1 times I times the square root of 2. I square root 2. And what do I have in the denominator? I have a 2. And that's it. You can rewrite this.
How did you get to that part? Like whenever you divided the 1 over, so the 3, you cross out the 3 and the 6 to get the 1 over 2.
I've canceled the 3. I can cancel a number when it's a factor in the numerator and denominator. So in the numerator, I have a 3. In the denominator, I have a 6. I can divide 3 by 3. I can divide 6 by 3. So in the numerator, I divided 3 by 3. When I divide 3 by 3, I get 1. I canceled the 3. When I cancel the 3, I have a 1 left. In the denominator, I have a 6. 6 divided by 3 is 2. So when I cancel the 3 from the 6, I have a 2 left over. So I've canceled. In the numerator and denominator, I canceled a 3. It's the same way you've been simplifying fractions for a while. If you have a fraction, let's say like 4, 40 seconds. Okay, let's say you have the fraction 4 40 seconds. To be able to simplify that fraction, you look for factors in 4 and common factors in 4 and 42. So does 4 and 42 have a common factor? And the answer is yes, 2 is a common factor. So how do you simplify that fraction? You cancel the 2. So you take the 4 and you divide it by 2. You take the 42 and you divide it by 2. So 4 over 42 and 2 over 21 are the same fraction. They're just in different forms. They're exactly the same number. They're just different forms of that number. And I did that by canceling a common factor. So the same is true for that 3 over 6. Since 3 and 6 have a common factor of 3, I can cancel it. And how do I cancel a common factor? I divide by that factor. So 3 divided by 3 is 1. So when I cancel the 3 in the numerator, I get 1. 6 divided by 3 is 2. So when I cancel the 3 in the denominator, I get 2. Let's see. Let's see, 10 over, I don't know. Maybe I don't want to do that. 30 over, I don't know. I'm just making stuff up. Okay, so look at the 30 and the 126. Are there any common factors in 30 and 126? And I think I made it 2 again. Actually, they might have another factor in common. I do know they have a factor of 2 in common, for sure. Because I can divide 30 by 2 and I can divide 126 by 2. So I can cancel a 2. When I cancel a 2, I get 15 here. When I cancel a 2 there, what do I get? 63? Is 126 divided by 62, 63? I think so. So it's 15 over 63. But 15 and 63 also have a common factor of 3. So I can divide 15 by 3, and I can divide 63 by 3, and is that 21? So 30 over 126 and 5 over 21 are the same fraction. I just simplified by canceling common factors. And I think I just rearranged it and got the real parts together. So I have I square root 2 divided by 2. So I can take the square root of 2 over 2 and write that in front and write the I second. And it's just a different, we're just using the commutative property of multiplication. We can write factors in any order that we want. It doesn't matter which factor comes first and which one comes second. 2 times 3 is the same thing as 3 times 2. It doesn't matter in what order we write them. As long as we're multiplying them, we can write them in any order we want. All right. How much of this I want to cover. I do want to review some laws of exponents, because we're going to use these laws in section 1.6. The first law of exponents is what happens when you raise a power to a power. Okay, and when you raise a power to a power, you can do that by multiplying the exponents. So b to the m raised to the n power is b to the m times n. For example, let's say you have 2 squared and you raise that to the third power. Now, what that means is, it means to use 2 squared as a factor 3 times. So use 2 squared as a factor 3 times. So this means 2 squared times 2 squared times 2 squared. Then what this means is you have 2 times 2 times 2 times 2 times 2 times 2. So this means 2 times 2. That means 2 times 2. That means 2 times 2. So how many 2's do you have? 1, 2, 3, 4, 5, 6. You have 6 2's. So what we've demonstrated is that we could have raised 2 squared to the third power by multiplying the exponents together by law. It's a law. So 2 squared to the third power is 2 to the 2 times 3 by law. That's what it is. So you can raise a power to a power by multiplying the exponents. So now if we have variables, let's say we have x to the third being raised to the fourth power. Well, by law, x to the third being raised to the fourth power, I can multiply those two exponents together. So this is x to the 3 times 4, which is x to the 12th. So I can raise a power to a power by multiplying the exponents. I can raise a power to a power by multiplying the exponents. Okay? Well, let's talk about square root. By definition, the square root of a number b is that number raised to the 1/2 power. That is by definition. That is what the square root is. So the square root is exactly the same thing as raising a number to a rational power, rational being a fraction. So also the cube root is b to the 1/3, or the fourth root is b to the 1/4. And again, what do we mean by cube root? Well, what's the cube root of 8? The cube root of 8 is the number that when you multiply it times itself 3 times, or you use it as a factor 3 times, you get 8. Well, what times what times what gives me 8? Well, that would be 2. And the cube root of 8 is 2 because 2 cubed is 8. That's the way roots work. So again, the square root can be written as that number to the 1/2 power. So what happens when you square a square root? So let's take the square root of 3 and let's square that. Well, by definition, the square root of 3 is exactly the same thing as 3 to the 1/2 power. They're exactly the same number by definition, by law. That's a law of exponents. Okay, now I just gave you another law that says when I raise a power to a power, I multiply the exponents together. So 3 to the 1/2 raised to the second power is 3 to the 1/2 times 2. You can multiply the exponents, multiply the 1/2 times the 2. But 1/2 and 2 are reciprocals. Now, what's the definition of a reciprocal? Oops, wrong one. A reciprocal is the number when you multiply it by a number, you get 1. So why is 1/2 and 2 the reciprocal? Why are they reciprocals of each other? Because when you multiply them together, you get 1. 1/2 times 2, the 2's cancel and you're left with 1/1. The reciprocal of a third is 3. because 1/3 times 3 is 1. The reciprocal of 2/3 is 3/2, because when you multiply 2/3 times 3/2, you get 1. And what is the reciprocal? By definition, the reciprocal is that value. When you multiply it times that number, you get 1. That's what it is. Now, how do you get the reciprocal? You take the fraction and you flip it over. That's how you get it. But when you multiply a number times its reciprocal, you always get 1. So what we end up with in that first row is we end up with 3 to the 1/2 times 2. 1/2 times 2 is 1. 3 to the first power is 3. So what happens when you square a square root? You get rid of the square root. Now, you could look at this another way. That's the second row down there. When you square the square root of 3, by definition, that means to use the square root of 3 as a factor twice. So that's equivalent to the square root of 3 times the square root of 3. By law, the square root of 3 times the square root of 3 is the square root of 3 times 3, by law. 3 times 3 is 9. The square root of 9 is 3. So what happens when you square a square root? You get rid of the square root symbol. And you end up with just the radicand. And now, again, what's the radicand? The radicand is the stuff underneath the square root. So the radicand here is 3. So when you square a square root, you get the radicand. Right? However, we use this to solve equations. So if I have the square root of x equals 4, what's x equal? Well, what do you take the square root of to get 4? 16? Okay, so what we do is we say, well, I could square both sides. Can I square both sides of an equation? Sure. Why not? Why not? The only problem is when you square both sides of an equation, you can introduce an error. And if you ever see something on the internet that they prove, like my son gave me some proof the other day where he proved that 0 equaled 2. And I said, well, you know 100% that if you have a proof, someone shows that 0 equals to 2, they've done a couple of things, one of a few things. They either divided both sides by 0, or they multiplied both sides by 0, or they did something like this where they squared both sides. They did something that was incorrect mathematically. So what happens if you square both sides? You can make something that's untrue true. So the square root of 16 is not equal to -4. The square root of 16 is the number that you square to get 16, and it's always positive. So this symbol here, this symbol is always the principal. I can't remember if it's PLE or PAL, but it's this principal root, which means the positive root. So it's not the negative. So the square root of 16 is not -4. The square root of 16 is +4. So when you square both sides of this, you can introduce what's called extraneous solutions. So when you square a square root, you get just the radicand, which is very beneficial if you're solving equations. But when you do that, you can introduce error. Don't you just love it when you do something mathematically and it can cause a mistake? That's kind of annoying, isn't it? Okay. Oh, I don't think I want to do this. Let's look at another definition of exponents. Okay, and this is a law, another law of exponents. If I have a being raised to a power, and that power is a fraction, and that number is a positive fraction, then a to the m over n is defined to be the nth root of a raised to the mth power, or it's the nth root of a to the n. For example, by definition, 2 being raised to the 3/2 power, the 2 in the denominator is our root. So since 2 is in the denominator of the fraction, we're taking the square root. And what are we taking the square root of? So that 2 right there means square root. What are we taking the square root of? Well, we're taking the square root of 2 to the 3rd power. So this number here tells me what I'm raising. Or we can write this as the square root of 2 cubed. That's the same thing. Exact same value, exact same number. So that you can prove this to yourself by taking the cube root of 8 and taking your calculator out and taking the square root of 2 and then cubing that result. You get exactly the same number. Okay, so the denominator in your fractional exponent is the root you're taking, and the numerator is what power you raise that to. So if we have like 2 to the, I don't know, 3/5, this means to take the 5th root of 2 and raise that to the 3rd power. So the denominator is our root, and the numerator is what power we raise that to. So that's the 5th root of 8. And what's the 5th root of 8? Well, whatever number you multiply times itself 5 times to get 8. And I don't know what that is. That's some irrational number. Or you could write this as the 5th root of 2 cubed. It means the same thing. And again, I don't know what that is. That's some irrational number. The 5th root of 2 is irrational. And remember, what's an irrational number? An irrational number is a number that you can't write as a fraction. So the 5th root of 2 is irrational because it's a decimal that never terminates or repeats. It just continues on indefinitely to the right, that decimal does. And then you take that decimal and raise it to the 3rd power. Or you can take the 2 and raise it to the 3rd power and then take the 5th root. It's the same thing. Okay, so let's do some simplification then. What's 8 to the 2/3 power? Well, by definition, this is the root. So we're taking the cube root of 8. That's my base. And then I'm going to take that and I'm going to square it. Or it's the cube root of 8 squared. Same thing, same number. So what's the cube root of 8? By definition, the cube root of 8 is the number that I multiply times itself 3 times to get 8. So that would be 2. 2 squared is 4. All right, let's do it the other way. What's the cube root of 8 squared? Well, that's the cube root of 64. And what's the cube root of 64? It's the number you multiply times itself 3 times to get 64. 4 times 4 times 4 is 64. All right. How about 16 to the 3/2? That means this is the root. So we're going to be taking the square root of 16 and we're going to be raising that to the 3rd power. Yeah, I just did this. or it's the square root of 16 cubed. Same number. Okay, and what's the cube root? What's the square root of 16? Well, the square root of 16 is 4. 4 cubed is 64. I just did that. Or it's the square root of, I don't know what 16 to the third power is. I have a calculator. 4,096. And the square root of 4,096, my calculator says, is 64. Okay, now what happens in this example? In this example, we're raising a power to a power. And when I raise a power to a power, I multiply the exponents. So when I raise a number to the reciprocal of its power, I get that number raised to the first power. The same is true down here. When I raise x to the 3/4 to the 4/3 power, I multiply the exponents. And when it happens, when I multiply exponents that are reciprocals, I get x to the first power, or x. Now we're going to save those. We're going to save that too. Actually, let's talk about this. The definition of absolute value, which I've kind of glossed over thus far, but let's talk about this for a second. What's the definition of the absolute value? Now, the definition of the absolute value is that it's the distance this number is from 0 on the number line. So if I ask you what the absolute value of 3 is, the absolute value of 3 is 3 because the distance 3 is from 0 on the number line is 3. So absolute value is a distance. And because it's a distance, it's always positive. So the absolute value of -3 is 3 because -3 is 1, 2, 3 units from 0 on the number line. So the way you find absolute value is if you're taking the absolute value of a positive number, you just drop the absolute value symbols. If you're taking the absolute value of a negative, then you change the sign of whatever that number is. So the absolute value of -3, change the sign of -3 to +3, and that's the absolute value of -3. So to find the absolute value, if the number is positive, you just drop the absolute value symbols. But if the number inside the absolute value symbols is a negative number, you change its sign. That's what you do. So how do you find the absolute value of pi minus 4? Okay, you need to determine, is pi minus 4 a positive number or a negative number? So take your calculator out and you have a pi symbol, or you can do it in your head. Pi is above the caret, above the power sign. If you take pi and you subtract 4 from it, you're going to get a negative number. So this stuff inside parentheses inside the absolute value sign, excuse me, that right there is negative. It's a negative number. It's negative 1 point something, or no, negative point, I don't know, 86. It's a negative, but it's negative. So how do you find the absolute value of a negative number? You change its sign. And how do you change the sign of something? You put a negative in front of it. So since pi minus 4 is negative, how do you take the absolute value of it? You change its sign. How do you change its sign in mathematics? You put a negative in front of it. So now when you distribute that negative across, so the absolute value of pi minus 4 is 4 minus pi, because 4 minus pi is positive. It's a positive number. When you take the absolute value, you have to force it to be positive. And honest to goodness, if you take pi minus 4, you get negative 0.86. The absolute value of negative 0.86 is positive 0.86. What's 4 minus pi? 0.86, same number. So again, if what you're taking the absolute value of is negative, you have to change the sign of whatever's inside the absolute value symbols. And I'm a minute over. Are there any questions? All right, we'll see you back here at 12:30.